lesson 1.5 today. This is page 33 in your workbooks. And we're going to, this should all feel pretty familiar because we're using equations or solving equations that use square roots and cube roots. There's going to be one little twist today that we kind of throw into the mix that we haven't done yet. But it basically, we're working with perfect squares and perfect cubes for the most part, and then they're going to throw in some irrational numbers as well. But I feel like today is not really all that super difficult. It's all doable. So let's look at our warm-up question here. So Janine can use up to 150 1-inch blocks to build a solid cube-shaped model. So what are the dimensions of the possible models that she can build, and how many blocks would Janine use for each model? Okay, so if she's got a tub, she's got 150 blocks, right? But she wants to build a cube-shaped building. So what do you know about cubes? Emery.
Well, they have the same length, width, and height.
Yeah, so it's got to be the same dimension going all directions, right? She can't build one long, skinny building. She's got to build it. It's got to be a square on all sides. It's got to look like a Rubik's Cube, right? So, so let's talk about how many or what possible size building she could build. So what's the basic, most simplest, like easiest one she could do?
6 by 6 meters.
Emery.
She could do 150 squared or cubes.
Well, we got to figure out if she can actually use all of them or not. So what's like the easiest, most basic, simplest thing you can do with a block to make a building?
One.
Just one block, right? If she's got blocks that are cubes, she could do one block, and its dimensions would be 1 cubed. So it would be 1 cubic, is it an inch? Inch. 1, so we would write that it is 1 inch cubed, right? That's how that would be written. All right. So what would be the next one that would be easy to do? She could do 2 cubed. And what is 2 cubed? How many blocks is it going to take to build it if it's 2 cubed?
8.
Okay, 2 cubed is 2 times 2 times 2. So that is 8 cubic inches, right? 2 cubes, if it's 2 by 2 by 2, it's going to be 8 blocks that she needs to build that.
Right.
Okay, then what are we going to do next?
We're going to do 3.
We're going to do 3 cubed, and what is 3 cubed?
27.
That would be 27 inches
I'm so
cubed.
smart.
By the way, we're just building a list of perfect cube numbers here, right?
4 cubed.
1 cube, hold on, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So we're building a list of perfect cubes. Okay, what would the next one?
64.
4 cubed is
I
64
said it first.
inches cubed. Okay, now the numbers are starting to get big real quick, right?
125.
5 cubed is 125 inches cubed. Okay,
I had a list. I don't know what 6 is.
I know what it is.
what is it?
I don't know.
Okay, it is 216 inches cubed. So have we figured that one out?
Yeah.
Okay, so what's the largest one she could build?
216 or 125.
Okay, so she could use 125 blocks to build a 5 by 5 by 5 building, right?
It's not really big. It's like 5 inches.
Well, it would be 5 inches on all sides, right? So it's, yeah,
It's not really big.
Actually, this is a
Okay.
square.
You can fit like 1 person in that.
so, all right, so yeah, the picture here actually shows what she could build. It would be 5 by 5 by 5. So it would be 5 layers of 25 blocks. If you look at the top one, it's 5 by 5, which is 25 blocks to make that layer. And then she's got 5 layers, which is 5 times 25 is 125.
Mr. Fish, you're so smart.
Thank you. Okay, so What does it say? I can't scroll. I guess I can scroll over here. It says something down lower here. Jasmine wants to build a model using 1/2-inch cubes. How many 1/2-inch cubes would she use to build a solid cube-shaped model with side lengths of 4 inches? So you got to think about a couple of things here. She's using 1/2-inch cubes, but she wants to make the side lengths 4 inches.
32.
So how many blocks does it take? How many 1/2-inch blocks does it take to make one side 4 inches?
No, it's double.
Remington.
64 times 2.
Now
That's
you
120.
have fallen victim to a very common mistake.
No.
Bryson. Okay, so that was the question I asked. Let's break it down. Listen, if she wants, you know how this one is it's 1-inch blocks, so 5 blocks make 5 inches. But if they were 1/2-inch blocks, it would take 8 of them to make 4 inches, right?
Yeah.
Okay, so if she use 8 of them going this way, and then, so 8 going this way, 8 going this way, and then 8 going this way. So what number do we need to cube?
8.
8, we need to cube 8, so 7 cubed, we need to make this list on out. So it's 343 inches, well, and we're not even gonna do the inches anymore, because we're just talking about cube numbers right now. So then we would do 8 cubed is 512. All right, 9 cubed is 729, and 10 cubed, I'd like you to have these written, by the way. 10 cubed is 1,000.
1,000?
1,000, okay, 10 times 10 times 10 is 1,000. So, we're gonna need these lists, kinda like we did the list of square numbers up through 10. It's good for you to have a list of cube numbers up through 10 as well for what we're doing right now. So, she would need 512 8-inch or 1/2-inch blocks to make a 4-inch square cube. Four cubic, oh, I don't even know how to say it. To make it 4 inches on all sides, which would be 512 cubic inches. All right.
Cool.
No, it would not be 512 cubic inches, it would be 64 cubic inches, but it would take 500, anyway, I need to stop talking. I've confused myself, I've said so much.
You
All right.
confused me, man.
Okay, she would need 512 1/2-inch blocks. There we go, that's all I need to say. All right. Let's move on to a video, yay, all right. So let's, let me plug in my sound here, I don't have it plugged in.
Sound.
All right.
Can't hear it.
How can you solve equations with squares and cubes? Think about this question during the lesson. Darius is restoring a square tabletop. The area of the tabletop is 25 square feet. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? Darius begins by drawing a diagram to represent the tabletop. He needs to find the length of the sides. Use the formula A equals S squared to find each side length. Darius knows A is equal to 25, so 25 equals S squared. To solve, take the square root of both sides of the equation. Why does Darius find the square root instead of the cube root to determine the side length of the square?
No, you need to find the square root.
But why? Why not the cube
It's
root?
squared.
Because it's a squared number. First of all, it's got the squared symbol next to the feet squared. But why is that the symbol? Why is it not cubed? Why is it not feet
Because
cubed?
it's a 2 and it's not
It's
a
a-
3.
It's a two-dimensional object that we're
Yeah.
talking about, right? We're talking about the top of a table, which is two-dimensional. We're not talking about the depth of the table. We don't need to worry about that. And so we only need 2 dimensions, so it is squared. All right, now, this next part is where we're gonna learn, yes, Bryson?
Why don't they just divide 25 by 2? You'll get 5.
No. 25.
Not 25 divided by 2, that would be
It's a
12 and a half.
square root, dude.
Square root, because, and they're gonna talk about this, because how did we find the area of a square? We did s times s, which is s squared, that's where they got this. And the opposite of squaring a number is taking the square root, okay? So we always have to do that inverse operation. All right, so, this next part, we've done this before. How many times have we done square root of 25 in the last couple of weeks?
5 times.
Like a bunch of times, okay? So this part is not,
25.
this part is not a surprise to us. We know what's going on here, but they're fixing to tell us something different about the math that's going on, okay? Something that we haven't considered yet up to this point. So here it is.
Darius needs to find the length of a square, given its area. The side length is squared, not cubed for area.
All right, so here it is. Here's something new to consider, all right? We're gonna go step by step through this problem. So we're at the point now where they left us in the video, where we're ready to solve this s square root of s squared equals the square root of 25. We've done this like a dozen times already, okay? But there's something new to think about. Here it is. There are 2 square roots of 25. True
Yeah.
thing, okay? Because what we're talking about here is what number times itself would give me 25. And 5 times 5 gives us 25. That's the one we've been thinking about, right? Well, that's the way we've solved this every time. But what about this? This is a true thing. -5 times -5 is also 25.
Yeah, but it's just.
Don't think about buts yet. We're not doing the buts yet. We're just, all we're doing is saying that from a mathematical standpoint, from the solution to the equation, it's true that 5 times 5 equals 25. It's also true that -5 times -5 equals 25.
What are you supposed to do?
So we'll talk about how we know which one it is in just a minute. Okay, so this new symbol here that they give us, we need to be okay with this symbol. It's a plus and a minus sign together. So we can say the answer is positive or -5, or sometimes we just say plus or -5. It's either a +5 or a -5, okay? And so the square root of any positive number could be a negative square root, or it could be a positive square root. We've got to consider that, because it's either one of them are true from a mathematical standpoint, okay? So we can write it as one equation involving plus or -5, or we can write it as s equals +5 or s equals -5. Most people just use the plus or minus symbol because it's so much simpler. It's less writing to do that, right?
Yeah.
Yeah, go ahead. So, we're gonna finish out the video, then we'll talk about some more examples, okay?
Cool.
In general, an equation of the form x squared equals p, where p is a positive rational number, has 2 solutions. X is equal to positive or negative the square root of p. So, the equation has 2 solutions. Which value of s will Darius use? Select your answer.
Now, let's talk about which one makes sense. We've got 2 possible solutions. We've got a +5, we've got a -5. Does it make sense for it to be one of those, or does it make sense for it to be both of those?
Both.
From a mathematical standpoint, it makes sense for it to be both.
But from, like,
But-
it's not gonna be negative, because that doesn't make any sense.
Yeah.
Making it.
We don't measure tabletops with negative numbers, okay?
But how do you?
So, we don't. So, the answer that makes sense is +5. So we're gonna choose that answer of the ones that they gave us, right?
The length of each side of the tabletop is 5 feet. Darius needs a total of 20 feet of decorative molding. Now you know how to solve an equation using a square root.
Now we know how to do it.
Kinda.
So when solving for square roots, which we've already been doing the last couple of lessons, but now we just need to add in that extra step of having a plus or a minus answer,
Okay.
okay? So, let's do this.
Yeah.
What is the side length S of the square below? Well, the
10.
area is S squared because we don't know the value of the side lengths, right? And side times side gives us the area. So S squared gives us the area of 100. So 100 equals S squared. So then if I take the square root of S squared, what do I have to do with the 100?
You gotta square it.
I gotta take the square root of 100. And so the
10.
square root of 100 is either a positive or negative
10.
10. And since we're taking the measurement of an actual square, which one of those do I want?
10.
I want the positive 10, okay?
Oh, that's what that means.
Yeah. All right. Why are there two possible solutions down here at the bottom? Why are there two possible solutions to the equation x squared equals 100?
Cause it's not, it doesn't have a, yeah.
Because now there are to just the equation right here we came up with two solutions, then we chose the one we wanted. But why are there two solutions here? Because positive 10 times positive 10 is 100, or
Negative 10 and a negative 10.
negative 10 times negative 10 is 100.
But wouldn't it go for like a negative 10 and a positive 10?
Negative times a positive is what?
Is it different?
Is a negative.
Yeah,
If
but-
we do positive 10 times positive 10, we get 100. If we do negative 10 times negative 10, we get positive 100. But what if you did negative 10 times positive 10?
Isn't it the same thing but not?
Negative 100.
That would be a negative 100. Negative times a positive is negative.
But does it
It's
matter?
not the same thing. Negative 100 is not the same thing as positive 100.
Yeah, that's true.
So you actually can't take the square root of a negative number. Because the square root means we need one number times itself, right? So I can't do any number times itself and get a negative number. So we're not gonna put negative numbers inside the radical.
Okay.
We don't do that, all right? So, let's move on. Let's talk about this. All right, Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. So what are the dimensions S for the screen? So if we've got a cube that has a volume of 343 feet cubed, what do I do when my I can't write on this screen for some reason. So sorry, this won't show up on the video if you're watching it later, but volume equals 343.
Yeah.
So how do I find the volume of a cube? Volume equals S cubed, right?
You square it.
Okay, so I need to do S cubed, it's not squared, it's cubed,
Yeah, cube. That's what I meant.
equals 343. So if I want to do, I do a cube root. And so do you have your list of cube numbers?
Yeah, hold on.
So S equals what?
7.
Okay? Now, do we have to consider anything else?
No, it's positive.
Why does it have to be what, but do we have to consider anything else mathematically?
It could be a positive or negative.
Could it?
Yeah, well, no, because it's a real life object. It's not negative.
But mathematically, do we need to consider a negative? Remington?
Yes.
No, because negative, it would be negative times negative.
Perfect. Okay, so
Oh.
listen. So for S cubed, if we're doing 7 cubed, that's 7 times 7 times 7. And guys, are you listening? Some of you are talking. So 7 times 7 times 7 would give you a positive 343. But what if you had negative 7 times negative 7 times negative 7? What is that going to be? Remington?
Negative 3. Oh,
Yeah.
yeah.
So that would be negative 343. So we do not, when we're taking cube roots, we do not consider the two answers. Only when we're doing square roots. Okay? So that, it gets a little bit confusing there, but only when you're doing square roots do you do a plus or minus. Cube roots, you just do a positive. All right? Okay, whoops. So there we go. Choose here.
Oh,
All right, so solve x cubed equals 64. So if we have x cubed equals 64, we need to take the cube root of x cubed, which means we need to do the cube root of 64. So x is 4. And that's it. X is 4. There's no other, we don't do a minus. Everybody good? All right. Okay, solve for x, and they take us through these first couple of them. Because what do you notice about x squared here? X squared is 50. What do you notice about 50?
50 is, I don't know.
It's not a what?
It's not perfect.
Not a perfect square. And so they're going to show us in the book, leave it in radical form. We're not going to change it to a decimal. We're not going to estimate it. We're not going to do anything with it other than we're going to write that our solution is either a positive or a negative square root of 50. So we leave it in the radical. That's easy. I don't have to solve anything. But I need to put the plus or minus sign to show that it could be positive or it could be negative. All right? It really is that simple. All we're doing is taking x equals plus or minus square root of 50. I mean, like super simple, right? What about cube root of a not a perfect cube? Well, they show us here too. X cubed equals 37. So there is one possible solution. It's the cube root of 37. I'm going to leave it in radical form. I'm not going to simplify it. I'm not going to change it to a decimal or anything. Okay? Super simple. So here's a couple of examples. We've got a cubed equals 11. So I'm going to take the cube root of both sides, which means that a equals the cube root of 11. It doesn't get any easier than that, guys. All right, this one, c squared equals 27, not a perfect square. So I take a square root. C equals plus or minus the square root of 27. It really is that simple. Okay, no tricks. Not like gonna change this, not gonna like pull the rug out from under you. It really is this simple. Okay, I'm gonna give you to the home, this is the review page. We're gonna get to the homework page here. I like doing the ones where we fill in the blanks together because sometimes the blanks are the hardest ones to figure out what they're looking for. So number 8, z squared equals 1. So if I'm gonna take the square root of square root of z squared goes here, and the square root of 1 goes there. So z equals plus or minus what? 1. So the solutions are -1 or, and I guess, not or, and +1. All right? And then fill in the blanks here. So cube root, we've got a cubed equals 216. So we'll take the cube root of a cubed, and then 216 goes here. So what's the cube root of 216? 6. Good. And it's only +6. We don't, with a cube root, we don't do a plus or minus. We just do the plus. Okay, so there's no other answers. All right, guys, you're taking either square roots or cube roots. If they're perfect squares or cubes, then you solve those out. If they're not perfect, you leave them as radicals. All right, have at it. What pages is that? 37, 38? 37, 38 is the homework.
Mr. Bishop.